Welcome to the Unit 1 video on experimentation. By the end of this video, you should be able to differentiate between quantitative and qualitative observations, differentiate between dependent and independent variables, and describe how to set up a controlled experiment to test a hypothesis. Let's start by talking a little bit about the scientific method. You'll notice here that I have the word "the" in quotation marks. This is because many people would argue, including myself, that there is no single scientific method. There's no single way of doing science. However, there are some useful terms and vocabulary we'll be talking about in this class. So it's useful to start out with some idea of what is generally accepted as the scientific method. Generally speaking, we start out with an observation or several observations. For instance, I might observe that, hey, every time I make tacos, my eyes start to water. From there, this might lead to a question. Gee, I wonder what it is that's making my eyes water every time I make tacos. From there, we might develop a hypothesis. I believe that it's the onions that are causing my eyes to water when I make tacos. From there, we might conduct an experiment. Perhaps I try each ingredient in the tacos next to my eyes to see which ones cause my eyes to water and which don't. And finally, we reach some kind of conclusion. Indeed, it is the onions that make my eyes water when I'm making tacos. Now, of course, this isn't a perfectly linear method. Often, the conclusion will lead to new observations and new questions and new hypotheses and new experiments. However, these are some key terms to keep in mind as we move forward. Let's start with the term observations. First of all, observations serve multiple purposes in an experiment. Often, observations can lead to questions, much like my observation about my eyes watering when I make tacos. Another example might be, hey, it seems like the volume of this balloon changes when the temperature changes. This could lead to the question, I wonder what the relationship between temperature and volume is. Likewise, observations can help us answer questions. For instance, I might observe, when the balloon is in a cold room, its volume decreases. This can help me answer the question about the relationship between temperature and volume. In this class, we'll be dealing with two different types of observations. The first type is a qualitative observation. Notice this term qualitative starts with the root qual, meaning quality. This does not involve a number. For instance, the crystals are green. The sample is heavy. The balloon is shrinking. These are all qualitative observations. None of them are measurements of any quantity. This is as opposed to quantitative observations. Here we have the root quant, meaning quantity. These include a number and are often thought of as measurements. For instance, the crystals reflect light at 520 nanometers. The sample has a mass of 75.06 kilograms. The balloon's circumference was 250 centimeters at 25 degrees Celsius. Each of these observations involves a measured number. Therefore, they're quantitative observations. So let's think about how we can design an experiment to test the relationship between temperature and volume of the balloon. I'm going to recommend that we vary the temperature and measure the volume of the balloon at each of these temperatures. Therefore, we can establish a relationship between temperature and volume. Of course, we have to think about what things we need to keep constant. These are factors that could also affect the volume of the balloon, but things that we're not interested in. We want to know about the effects of temperature on the volume, nothing else. So we'll need to make sure we keep things like air pressure or amount of air in the balloon constant. If we also varied these things, the change in the volume of the balloon could be attributed to these factors instead of to temperature. And since we're only interested in temperature, we want to make sure to hold them constant. This brings us to the idea of variables. In this class, we'll be looking at two different kinds of variables. First, the independent variable. The independent variable is the factor that is varied or manipulated in an experiment. This is often thought of as the cause. In other words, it's the thing that causes the effect that we're measuring. When we graph our dependent and independent variables, the independent variable will go on the x-axis. Thinking about our example with temperature, where we vary temperature and measure the effects on the volume of the balloon, temperature would be our independent variable because it's the thing we're varying. Dependent variables, on the other hand, are the response that we measure. These are often thought of as the effect of the cause. In other words, change the temperature and we'll measure the effect on the volume of the balloon. This goes on the y-axis for a graph, and in our example again, the volume of the balloon would be the dependent variable. The volume of the balloon depends on the temperature, which we're varying. Finally, let's talk a little bit about data. Data is something we'll be collecting and manipulating and displaying a whole lot in this class this year. There are two main ways to display data that we collect, either in a table or in a graph. Often, we'll be using both. A table should always include units for everything that we measure. Here's a table showing some data one might collect for our temperature volume experiment that we've been talking about. Notice in each case we have units for both our temperature and our volume. And again, we varied our temperature, making it the independent variable, and we measured the resulting volume, making it our dependent variable. We might also graph this data. Graphs should always have a title, labeled axes, units on these axes, and a proper axis scale. For instance, if we graph the data at the left, we end up with a graph that looks like this. This graph has a title, it has labeled axes, it has units on these axes, and it has a proper axis scale. We know this because our data is roughly centered in the graph. This brings us to the end of the experimentation video. Let's quickly review our goals. First, we learned to differentiate between qualitative and quantitative observations. Remember, quantitative observations involve a number, whereas qualitative observations are merely a quality of the substance or the thing under study. We also learned to differentiate between dependent and independent variables. The independent variable is the thing we manipulate, and the dependent variable is the variable that we measure. And finally, we talked about how to set up a controlled experiment to test a hypothesis or explore a question. Keep in mind that it's important to control other factors that might affect the variables we're looking at in an experiment.